Hi everyone, welcome to this webinar. Just waiting a few minutes for others to join. Thank you. Hi everyone, welcome to this webinar. We're just waiting for a few minutes, letting others to join. Hi everyone, welcome to this webinar. We're just waiting for a few minutes and we'll get started. Hi everyone, we're just waiting for a few minutes and we'll get started. Hi everyone, welcome to this webinar. Okay, I think we'll get started at this point. Good morning, good afternoon everyone, and thank you for joining this webinar. Really excited to be hosting this one today. This webinar will cover how to tame hybrid multi-cloud complexity using EfficientIP's Unified DDI solutions. So, I'm delighted to be joined today by Sherif Tonsi, our Customer Solution Architect Manager. Sherif leads our pre-sales activities in Southern Europe, Germany, Austria, and Switzerland. He's got deep expertise in networking and security, some of which he will share with us today. Hi, Sherif.
Hello, everyone, and welcome to this webinar.
And I'm Miriam Airborne, Product Marketing Director here at EfficientIP. Before we get started, just a few quick housekeeping notes. Today's session will last about an hour and is going to be split into 3 parts. We'll start with a brief presentation, followed by a live demonstration. Then we'll wrap up with a Q&A session. Feel free to ask questions in the chat at any time. We'll address them during the Q&A at the end. This webinar is being recorded, and you'll receive a link to the recording along with the presentation slides in the coming days. We hope you enjoy the session and walk away with valuable insights. So, what's the agenda for today? I'm just going to start off talking about hybrid cloud adoption, what's driving it and the challenges it brings. For those of you who aren't familiar with EfficientIP, I'll briefly introduce our unified DDI solutions and how they help simplify hybrid cloud complexity. To illustrate, we'll explore 4 key capabilities they deliver: centralized management, effective network source of truth, robust automation, and network observability. Next, we'll take a look at best practices for building a successful hybrid cloud journey. I'll hand over it to Sherif for the live demo. You'll see our network source of truth in action, how it drives automation, as Sherif demonstrates how to use EfficientIP solution to orchestrate the design, deployment, and deletion of a virtual machine. Finally, we'll wrap up with some key takeaways and then open the floor for your questions during the Q&A. Sounds really exciting. Let's get started. Here is an interesting prediction from Gartner that captures the momentum behind hybrid cloud. 90% of organizations will adopt hybrid cloud through 2027. It's true that applications are no longer confined to a single data center or network. They are distributed across fragmented networks, on-premises, private cloud, public cloud. Hybrid multi-cloud architectures are now the norm, driven by the desire for greater flexibility, scalability, and agility. What this tells us is clear. Hybrid and multi-cloud environments are the new reality that most organizations must actively deal with. But these shifts come at a cost. It creates more complexity, reduces visibility, and increases the potential attack surface for cyber threats. As we can see on the slide, IT teams report facing several key technical challenges. First, fragmented management. Many respondents say they lack centralized control over IPAM and DNS. This is because teams have to work across different tools and interfaces coming from the different cloud providers. This leads to issues like IP address conflicts and overlaps, which impact service availability and overall network performance. Planning and allocating IP addresses across multiple clouds and on-prem environments becomes a complex task. Second, insufficient automation. Automation between IPAM, DNS, and DHCP systems is often limited or poorly integrated. As a result, even simple tasks like updating an IP block or modifying a DNS record can take much longer than necessary, making network changes tedious and risky. These two challenges naturally lead to a third, security and compliance risks. Fragmented management creates fragmented visibility. Teams struggle to maintain control and visibility across their entire network. Managing DNS becomes a major pain point, and security, it is even harder, leaving organizations more vulnerable to DNS-based attacks. On top of that, it's difficult to consistently update, enforce, and audit security policies across multiple platforms. This creates breaches and compliance failures, as well as potential audit issues. In terms of business impact, these challenges slow down operations, delay deployments, and can lead to costly errors and financial consequences. These challenges directly impact how successful organizations are with hybrid multi-cloud. As we can see from the slide, and according to the latest EMA report on enterprise strategies for hybrid multi-cloud networks, only 25% of organizations say they've been fully successful in building and operating their hybrid cloud environments. Success remains elusive for most. So, what can organizations do to address these challenges? Here's an interesting quote from the EMA report. Network automation is an essential enabler of mitigating cloud environment complexity by streamlining operations and imposing standards. Automation can therefore play a major role in taming network complexity and reducing the challenges and risks it brings. And this is echoed in the voice of IT teams as shown on the slide. When asked about the key drivers for network automation, IT professionals overwhelmingly pointed to cloud migration and hybrid multi-cloud environments, as we see as they are top of the list. It's clear, as network complexity grows, automation becomes essential. One powerful way for IT teams to manage this complexity is by embracing network automation. That's where EfficientIP's Unified DDI solutions come in. For those who may not be familiar with our solutions, here's a quick overview of our portfolio. It's built around 40 unified solution arrays. Let's walk through them from left to right. First, core networking services. This includes fully integrated DNS, DHCP, and IP address management, commonly known as DDI. These are the backbone of your network. They come with advanced DDI observability and analytics to monitor DNS traffic and DDI services health in order to optimize network performance. The result? End-to-end visibility, faster deployment, and high service availability across your infrastructure. Second, network automation. We offer tools that, combined with integrated DDI, help drive network automation. These tools include comprehensive asset discovery and inventory that go far beyond DDI resources, including IP, address, and space, IP plan, VLANs, VRF, applications, objects, and devices, along with their metadata. This will enable you to build and maintain a reliable network source of truth, laying the foundation for scalable and robust automation. Third, adaptive DNS security. This is our DNS-centric security solution designed to protect, detect, and respond to the widest range of DNS-based threats. It acts as your first line of defense, safeguarding both public and private DNS infrastructures across networks. It enables your teams to manage DNS attacks throughout their life cycle, ensuring data protection, service continuity, and operational efficiency. And fourth, intelligent application traffic steering. By leveraging DNS-based global server load balancing, this solution optimizes application routing and performance across distributed environments. That means faster, more reliable access for users, no matter where they are, while also boosting resilience and supporting disaster recovery. All these unified solutions are delivered through our solid server and cloud-based platforms, supporting flexible deployment models on-premise, virtualized, and across public, private, and hybrid cloud environments. Together, they deliver visibility, automation, performance, security, and resilience, empowering you to meet today's challenges and scale for tomorrow's growth. Now, let's take a closer look at 4 essential capabilities these solutions provide to streamline operations in hybrid multi-cloud environments. And let's start with the first one, centralized management. EfficientIP's Unified DDI provides powerful overlay management across hybrid multi-cloud and on-premises environments. From a single pane of glass, IT teams gain full control over IP address spaces, network resources, and DNS services, streamlining DDI management even across multiple vendors, as we see from the slide. This centralized approach helps prevent IP conflict, detect unauthorized devices, and reclaim unused IP addresses and ports, thanks to built-in checks and configuration consistency controls. The result is more efficient use of IP space, stronger DNS integrity, and easier scalability. It also supports enforcement of corporate policies across the infrastructure. On top of that, by automating the management of multi-tenant IP plans with DHCP and DNS services, our Unified DDI reduces manual errors and operational inefficiencies, making it easier to adapt quickly to hybrid cloud environment and shifting demands. Second key capability is our effective network source of truth. But for those who aren't familiar with what a network source of truth is, let's see and read together the definition. In simple terms, it's the authoritative reference that represents the intended state of your network. Think of it as a blueprint for how your network should be, designed and structured by you. This intended state is captured as structured data, which means it's organized in a way that other systems and tools can seamlessly integrate and interact with programmatically. Now, this is different from your actual network state, which is what's actually connected on your network as retrieved from discovery tools. The network source of truth focuses on what the network is supposed to be, not just what it happens to be right now. Using a network source of truth requires a bit of a mindset shift. Instead of managing your network through scattered documents and diagrams, you're centralizing everything into one consistent, structured dataset. That dataset becomes a foundation for reliable network automation. Because what matters, especially when it comes to automation, is that automation only works if the data behind it is accurate and consistent. If your inventory of IP addresses, devices, or network properties is incomplete or spread across different systems, automation can break down. That's why a network source of truth is so critical. It allows you to store and manage everything from devices, objects, network topology, IP addresses, DNS records, and their metadata like location and more. Everything in one place and exposed through APIs to drive scalable, reliable automation. And this is what we bring. EfficientIP's network automation tools are built around a powerful network source of truth. At its core is a rich, trusted, and actionable network data inventory that goes far beyond just DDI. It includes VLANs, VRFs, applications, network objects, devices, all what you see on the screen and even more, and their related metadata. We use a flexible, structured data model that manages complex relationships across these multiple layers. This ensures consistency. We also offer a custom object class, giving you the flexibility to support specific tailored data needed to map and build your own business process. You'll see this in action during the demo. Then our network discovery tools play a key role too. They help consolidate assets across cloud, on-prem, and hybrid environments. They continuously track changes, list errors or inconsistencies, and compare the intended state, what's in network source of truth, with the actual state discovered on the network. Actually, this is what our solution is doing. When inconsistencies are found, we provide ways to remediate them directly from the solution. This automated reconciliation ensures high quality and reliable data and helps simplify change management as well as configuration drifts, which is critical for network assurance. And finally, all this data is accessible through open APIs. These APIs aren't just for pulling data out, they also allow you to ingest data from other systems. This keeps your network source of truth enriched and up to date. That means your network and security teams can easily push and pull data across the ecosystem, feeding the network source of truth, automating workflows, and eliminating repetitive tasks. This is what you're going to see in the upcoming demo. Third capability, very logically robust automation. As we've seen, Thanks to our effective network source of truth and unified DDI solutions, we enable IT teams to seamlessly connect and integrate with a broader network and security ecosystem. Here on the slide, you see the list of partners we integrate with. Our solutions act as a network automation hub, giving you the foundation to scale this robust automation across your infrastructure. To make integration easy and flexible, we offer multiple options tailored to different levels depending on what you need. First, no code, that is ready to use off-the-shelf plugins that you can simply install and start using. And from the names you have on the slide, there are a couple of them available. Low code is a second option, requiring just minimal coding or configuration to get up and running. And pro code. For full customization, for bespoke integration, you can leverage our rich open APIs and documentation that let you build exactly what you need. So whether you're looking for quick deployment or deeply tailored workflows, we got a tool to support your automation strategy. Finally, last capability is network observability. As part of our core networking services and DNS security solutions, we provide powerful DDI metrics and DNS analytics delivered through a cloud-based platform. From this single pane of glass, you have full visibility into DNS traffic and performance across your infrastructure. You can easily monitor activity, detect anomalies such as DNS latency or potential DNS threats or even DNS attack, so malware or phishing, and troubleshoot issues quickly and effectively. The result, an improved performance, stronger security posture, and optimized network operations. So based on that, let's summarize key best practices for a successful hybrid cloud journey. Let's walk through the key steps here we see on the slide in order to build that successful hybrid cloud journey. So first thing, to manage the complexity of hybrid cloud environment, first thing is to start by prioritizing centralized management of your IP address space. Indeed, as environments grow more distributed, having a unified view across on-prem, public, and private clouds is essential to avoid IP address conflicts and maintain control. Second, leverage the full DDI integrated solution, overlay solution, like what we've seen with our unified DDI solution. This ensures your DNS and IPAM services remain consistent, unified, scalable, no matter how complex your infrastructure becomes. Third, implement and start feeding a reliable network source of truth. This gives you a single authoritative reference for network resources across hybrid environments. When combined with automation, it ensures seamless provisioning, updates, and decommissioning of resourcing, saving time and reducing errors. And finally, use observability through DDI observability and DNS analytics, as we've seen, to monitor the overall network performance and reinforce your security. By analyzing in-depth DNS traffic and service health, you can proactively detect threats, troubleshoot faster, and optimize your operations. Together, these steps provide a solid foundation to simplify hybrid multi-cloud complexity and scale confidently. And there's more. EfficientIP's unified DDI solutions go beyond that technical implementation. They help drive hybrid cloud success by acting as a shared source of truth across IT teams. It's network, cloud, security, all together. They can share that same source of truth. And this will drive alignment. This will improve efficiency and enables greater agility across the board. And we know, according to EMA, that 69% of organizations that rate their hybrid multi-cloud networks as completely successful also report strong collaboration between their cloud and network teams. So that's very much important to find ways to increase collaboration of IT teams, and you can start doing it, or at least EfficientIP Unified DDI solutions is an enabler to that collaboration. This ends my presentation, and now let's see it in action. Sheriff, over to you.
Thank you very much. Okay, can I just get, yeah, perfect. Thank you, Miriam. Let's go now for a demo regarding automation in an hybrid and multi-cloud environment. So let's think about a scenario that probably everyone here knows, which is a VM creation. But imagine it in a hybrid and a multi-cloud environment. So you probably need to create VMs in different public clouds or private clouds providers, or even on on-premise. So we will show how to easy this process using automation and EfficientIP services and features. We'll start by step one, which is designing a VM, like an architecture team that does every day, and then we will deploy it and delete it at the end. In order to make it happen, we have put in place an environment based on, of course, our solution, which is a solid server EfficientIP. More than that, we are using three main features for that, which is Network Object Manager, IPAM, and DNS. So IPAM and DNS are including in the core systems with DHCP in order to do the DDI. And Network Object Manager is a centralized repository of virtual and physical devices that can be connected or not to the network, of course, but it's serving as a source of truth for any network object that can be inventoried, like switches, routers, I don't know, VMs, servers, or IoTs. Then we have an orchestration platform based in the lower levels on Ansibles and some Python scripts, but we have an extra layer with Kestra in order to ease the automation and to have more, let's say, graphical interface or UI. We are using a solution which is Redis to get events, just a bus that reads events in order to start to have the, let's say, the go for starting an orchestration. And we have our instance in AWS where we will try to create VMs, or EC2 to be exact, by the automation process. So if I need to go here, you have the three solutions that I have shown: our platform, the Kestra for the orchestration, and the AWS platform. So a quick tour on our solution. So EfficientIP UI makes you able to use all the features in the same interface. So you have the DDI, DNS, DHCP menus, and you have others for discoveries like NetChange and Cloud Observers. But the one which we'll use today is, as I said, the Network Object Manager. So if I go in the Network Object Manager, I will find different folders that define, for example, area or applications. You can define it as you want. Here we have basically a folder that contains a platform for any application. So we will create a new VM here as an architecture, as a design mode. Let me just give you a quick tour on the different steps of the VM before doing that. So first of all, we will define a new machine, a new VM in a design state. Then we will change the action to start it. So the starting will make this machine created and many things done, and I will explain you in parallel what will be done automatically. And so the machine will be in a running mode. We'll be able to stop it or to delete it in order to change the original state. If I come back to my platform, let me just create a new machine. Basically, I have to do to get a name. So let's give it like my business app, for example. I can give a description. For the type, I will define that it's a VM, of course. In the states, I'll say that I will start by a design mode, design state. So we are just thinking about the machine that we will use. We are not deploying yet. I don't need any patch. So here I don't need to change the state for the beginning. Let's define what cloud I can use. So I want to deploy this machine on AWS. It could be on Azure, on Google, on OVH, but all others. Just an example here, it can be on-premise on your VMware platform, for example. What is the network that is related to this AWS tenant? Let's say, for example, let's deploy it in this subnet, which remains on Boston, for example, but it can be on Paris, it can be on any data centers of Amazon. And what is the size of the VM? Let's keep the smallest for the example. Another question here is, do I want this machine to be accessible and reached at the top, at the beginning? So let's do that. It will define what is the FQDN, the DNS record that is related to this machine. It's my business app automation and demo. And let's make OK. So for the moment, I just created an object on our platform. So far, so good. It's in design mode here, and there is no change of state. Let's edit it now and just change the state. So I want it to start. And I make an OK. You can see here that the intent state has been changed. We are still in design, and the automation process has started. So what is happening behind the scene? If I go to the orchestrations and go to the flows, I will see the flows that is related to my machine. If I go on topology, so what will happen exactly for the action to create. So first of all, the bus will get the change of state coming from nothing to start. We will find the correct switches and correct networks. Then we will start the action. It will send, first of all, a notification that I have received in parallel saying that the automation has started. And we will start the creation of the VM on Amazon. In order to do that, we will ask the IPAM of an unused IP in the subnet that we have defined. Then we will update the IPAM saying that now this IP is related to this new VM. The VM creation can start, and then we are able to make update inside the EfficientIP, which are the FQDN, the name of the VM, the states, and also the DNS records that is done. Everything can be checked here. So it's still running. We can see in the execution the time that it will take. So here, if I go to the Gantt, I can see what is still in work and what was already done. So the VM creation was done. The SDS update was done, and now we can see that everything has been finished. If I go to Amazon and go for the list of my machines in the instance, I will see now that I have my business app machine that is running in a running state. I can click on it. I can check that it has this IP address given by the IPAM, the EfficientIP IPAM, and it has this ID, etc. Now, if I go back to the NOM, Network Object Manager, and make an update, I'll see that my machine now is in running mode and there is no intent to state. It's running. We will find the same IP address. More than that, more than the network source of truth for the devices, let's go for the addresses, which is the IPAM. If I go to the automation part, I will see here that in the subnet, I have now the record of my machine with the same MAC address that was given by Amazon for this machine. And I will also, if I go to the DNS server and check in the related zone, I will find that the record has been created with the correct IPs also. If you know or don't know EfficientIP, you should know that we have a global search tool here. So if I make a search, I will find also that all the information related to this IP are now accessible from one single plan. It can be the IP with all the information related to it in the IPAM, in which subnet, in which block, in which space has been created. I can see that I have the DNS record that we have seen, the machine that is present in the Network Object Manager, but also the related interface that is matched to this machine. If I go back to Network Object Manager and click on my running machine, I can see that I have also defined an interface with the correct IP and with the correct address MAC. Now, if I want to continue in another state, I can basically go back to the machine itself and just change the state one more time. So it's currently running. Let's for example stop it. So making a stop is not something very complicated to do. It's an execution that will basically, if I go back to the flow and check for the topology, the stop will send a notification and we'll just ask Amazon AWS to stop the VM and change the state in Network Object Manager on EfficientIP platform. So if I go back here, if I go to all the instance, let's see if it's still in running. So it's to check past. Okay. This is stopping. I have received a notification that the action has started. So the bus has checked the information. Let's see in action here in the current executions. What is running? Okay, the machine has been stopped on AWS. And if I go back to EfficientIP, I'll see now that my machine has been stopped. But if I make a search, I will still find or the information related it, because we have just turned off the machine. Now let's do the last thing, which is deleting the machine, because as for example, an IT ops team, I have to deploy and delete many platforms for many reasons, for a new application, for testing the application in different levels like production, pre-production, test lab, or something like that. So I just want to delete it now. If I click on OK, so as you know, the state was in stopped, but the intent state was to delete. So if I go back to the orchestrator platform and check what is the process is a little bit more complicated than stopping. Basically, we will get the action that we want to delete. We will send a notification that the information has been get from Network Object Manager as an event, and we will start deleting the VM. Before deleting it, we'll make updates on the EfficientIP, which is the network source of truth. We will make this IP now as free IP. We will delete the DNS records, which is related. We will change the state in Network Object Manager, and we will, of course, delete the VM on AWS. If I go on AWS now, if I make an update, the machine is in terminated mode. So it does not exist. It's a mode where AWS keep that during 1 hour. If you come back in 1 hour, you will not see anything here. So the My Business machine will be deleted. And if I come back here and make an update, you can see that the machine was deleted and there is no intent states. If I make a global search, I don't find anything. I find the subnets, because we have not deleted the subnets, but the IP itself or the record and or the interface has been deleted from the network source of truth. Let's check it very quickly. Nothing. I was in this subnet, so nothing. And if I go back to DNS in the same zone, the record has been disappeared. So imagine that you are working in an hybrid and multi-cloud environment. You have to, for any reason, you have to deploy a new platform for a business application. This application needs 3 VMs, one in Amazon, one on your private cloud provider, and the third one on on-premise. You can just design it from a single pan, and then with automation, make everything happen and get all the needed network information in the network source of truth as NOM and or IPAM. I hope it's clear for you. So let's make the demonstration. I can go back just 1 second. Something interesting to understand is that when you install the EfficientIP solution from scratch, you have an object model for what is an IP, what is a network, what is a subnet. And you are able, with the built-in and the custom object class, you are able to add all the attributes that you want regarding all kind of object in order to make it easier for you to define what is this object in your situation. If I come back, for example, here, if you remember well, I had to create, to define what is the cloud, what is the network, what is the VM size for a machine. This attribute has been added on a basic network object in order to define what is needed for this use case. So EfficientIP is really customizable in order to let you define the object as you need. If you need more attributes, you are able to do it really easily.
Thank you very much, Sharif. The demonstration was very insightful. Actually, you connected the dots between what we've covered in the presentation around network source of truth and robust automation and what you have demonstrated to us today. So what's really important to understand is that we are just changing the way to design and operate networks. Now this is done thanks to a network source of truth that enables IT teams to drive the modeling, planning, and automation of networks. And this is really important to acknowledge and recognize, or at least understand what we've been able to see. Of course, it's a journey, and it may take time until being able to manage the entire infrastructure using this powerful tool, but it's there, it does exist, and it's what we are adding to. If you want to play with this demo, we've made material available from the GitLab. You have the link here, but you'll also receive the slide, so you'll have everything you need in order to access the files which we've uploaded on the GitLab. And so feel free to check it, to practice, to use it, experiment it, or get inspired with it. And we'll be very happy if it can help you in your daily activities. So just a few key takeaways before wrapping up this session. So what we've seen, and we hope you have understood the really benefits brought by EfficientIP Unified DDI solutions and how it helps simplify hybrid cloud complexity and help you gain efficiency in your operations. Remember the 4 key capabilities we've gone through: centralized management of IP address plan and DNS services, effective network source of truth, or robust automation, and DDI DNS observability. All of this, along with fostering the collaboration between IT teams, are the ingredients for a successful hybrid multi-cloud journey. Thank you for your time. We hope you've enjoyed the session, and we can now open up for the Q&A. Okay, we've got a few questions. Our first one: do you already have the environment configured to be able to deploy it in Google Cloud Platform, AWS, or Azure, or others?
So do you already have the environment configured to be able to deploy it in? It can be different questions here. If the question is it possible to deploy EfficientIP in Google Cloud, Amazon, or Azure? The answer is yes. We have the correct images for that. And if the question is, are we able to integrate and deploy VMs using automation? The answer is also yes. We have displayed that during the demo for AWS. It's pretty the same with Azure and GCP, so could be done.
Absolutely. So I guess you got it, Sharif. So there's no impossibility to do it. Of course, this will require some adaptation to what we put together and make available for you today. It's not just ready for use with GCP and Azure, but it can totally be done the same way we've done for you today. Second question: where do I see the public IP address of this VM in EfficientIP box?
Great. So the answer for that is related to what we have seen regarding customization. For the demo, we have not done the integration of the IP or the public IP, but basically, if we wanted to do, we were able here in the main IP, we would be able to add an attribute which name is main public IPs. If it's defined by AWS itself, meaning Route 53, we will just get it. But if the public zone is hosted in the DNS of EfficientIP, it will be exactly the same. So you will find it here as another column, and we'll be able to display it.
Thank you, Sheriff. Adding to question 1, do you already have the environment configured to be able to deploy it in GCP, AWS, Azure, or others, if the environments have the details, credentials, and whatever it is needed to be able to deploy the VM? So I assume this is what we covered with our second answer. So I think we addressed the question. Question 3, in our scenario, we are implementing automation with Terraform using the solid server provider. Will the provider be updated to enable access to the cloud server component of solid server?
The cloud server component.
Okay. In between, while you were thinking about possible response, I just would like to highlight that what we did today with Kestra and using Ansible and Python, like Sheriff mentioned, can also be done with other YAC infrastructure as code tool like Terraform or any other else which you are using.
So the APIs are okay. You mean, as far as I have understood, the current plugin for Terraform has not the ability to discuss with Cloud Observer by design. So, okay, we need to update it with in order to, let's say, to integrate the APIs. But you can do it because the APIs of Cloud Observer are also available, and you can use it using the same method. You just have to get the method and integrate it in your Terraform plugin. So we can do it, or you can do it. It's already published in the APIs.
Thank you. No other questions at the moment. Okay. Perhaps just wait 1 minute more.
Of course.
Anyway, if you have any questions, even after that session, feel free to reach out to us, and we'll be happy to get back to you. Other than that, thank you for your time. We hope you found it valuable and insightful to you. We enjoyed the session, and we hope to see you soon for another webinar. Thank you very much, Sheriff, again for the time. And,
you're welcome. Thank you, Miriam, and thanks to everyone.
Thank you. Have a good day, everyone. See you then. Bye-bye.